Okay, the second part of the lab is Bayes application. So we talk about the example in classroom. So the data a little bit different. So suppose 1 in 10,000 people have certain virus infection. A medical test has the following properties. If somebody actually infected, test yields a positive result. Probability is 99%. If he's not infected, the test come back positive result with a probability 5%. That's the false positive. So the first we need to find out if test positive, what's the probability he's actually infected? So we need to put into what we already know about the infection, about the test, the probability here, and then we use Bayes' theorem to calculate. The second part is if tested twice, both positive, what's the probability he's actually infected? And the number 3 assignment for this part of the lab is to draw a diagram. We like to know the relationship between the probability he's actually infected, so if he tests positive, versus the infection rate. Okay, so the first part, we need to write down what is given here. So here I already put, we call template, so that's easy for you to type in the values. So infection rate, if you random select a person, infection rate is 1 out of 10,000. Not infect, that's 1 minus this value, right? That's the complement of infect. Somebody infect and test positive, that's 99% probability. Not infect, test positive, that's 5%. This is given, okay? So first we need to find out what's the probability overall. If I random pick one, he's positive. So that's equal to, we separate into 2 groups. Remember that the first group is infected, positive, multiply the probability infected, plus this person not infected, and multiply the probability not infected. So this is the probability positive. Random pick a person, he's positive. So now, out of this positive person, say if he's positive, so what's the probability he actually got infected? That means we need to find out this group, infected and now test positive, okay? Out of overall test positive, okay? So this is how we find out. So next question, if tested twice positive, so how can we find out the probability he's actually got infected? So this is very interesting. Tested twice positive. So that means the infection rate for this person is not 1 out of 10,000. He's not just a random, see, in the population. It's like he already tested positive. So we call prior probability. So his infection rate changed, equal to this one, right? So it's not 1 out of 10,000. It's much higher because he already tested positive. So not infected, that's 1 minus this value, okay? And this about test, if infected test positive, the test, the positive rate is still the same. If not infected, that's still 5%. And we also can copy paste the formula here. So that's a good thing about, so I just copy and right click. We want the formula only, see formula. So this formula, the positive is you infected and infected positive, you're not infected, and what's the positive rate? We add together. That's the overall positive. So this is slightly higher now. So if you test positive twice, so again, right? So how likely you got infected, that's equal to you infected and test positive divided by out of this group. See, this time much higher than the initial if you only test once. So for the second part, if someone tests twice positive, what's the probability he's actually infected? I also have a way using a tree diagram to solve the problem. So you can look into this. So it should have the same solution, okay? So twice positive, you only look at the branch. Who is twice positive? So infected, tested twice positive, and also not infected. It could be twice tested positive, okay? So you need to find out this is the group test positive twice, and out of this test positive twice, how likely got infected is this branch, okay? So the last assignment for this lab is to just plot to find out the relationship of infection rate. Now is 0.001. So if the population, the infection rate increased, how about if you test positive? What's the probability you got infected? So what I'm doing, I just copy the results here, paste the value, not just paste, only paste the value. And then you change this to say 0.001, okay? Now the infection rate, if you test positive, getting higher, so you paste here, value. So once you fill this table and you plot the scatter plot, and x-axis is infection rate, and the y-axis is this probability. If you test positive, what's the probability you got infected? And then to write like 1 or 2 sentences to see what's your finding. Okay, that's the lab about the Bayes rule.